In this slide, we are taking a high-level view of supervised learning in machine learning, focusing on the fundamental concept of using features to predict an outcome. At its core, supervised machine learning involves using features, which are the input variables, to predict a target variable, the outcome we are interested in. This process is akin to what we do in everyday life. We observe various factors, features, and predict outcomes based on these observations. For instance, seeing dark clouds and feeling high winds can lead us to predict that it will rain. Similarly, we assess people's clothing and interactions to predict whether we will become friends with them. Employers often predict a candidate's suitability for a job based on their resume, which includes features like education, experience, and skills. In business, supervised learning has numerous applications. Companies use it to predict customer behavior, such as whether someone will buy a product or click on an ad. These predictions help businesses tailor their strategies and improve their decision-making processes. To better understand supervised learning, it is important to familiarize ourselves with some key terms. Features are the input variables, while the target variable is what we aim to predict. Training data is used to build the model, and test data is used to evaluate its performance. The model itself is the algorithm that makes predictions based on the features. Let's explore the two main types of supervised learning: regression problems and classification problems. Both use labeled data to make predictions, but differ in the type of output they aim to predict. Regression problems involve predicting continuous outcomes based on input features. For example, predicting the fair price for an Airbnb listing by analyzing current prices and customer willingness to pay is a regression task. Classification problems focus on predicting discrete outcomes or categories. Analyzing a patient's medical history to estimate the risk of developing a condition is a classic example, where the task is to assign the patient to a risk category. If the label is a continuous value, it is a regression problem. If it is categorical, it is a classification problem. Understanding these distinctions is key to effectively applying supervised learning techniques. That begins our look into supervised learning. See you in the next part.